Good morning to one and all present here. See here I am just going to have an introduction part. Myself, Ms.A.M.SERMAKANI, Associate Professor, Department of IT, S.A. Engineering College. As you know that S.A. Engineering College was established in the year 1998 and it is having a well infrastructure for covering all the courses like B for EC, EEE and then Mechanical Civil Department, and we have CSE, IT, and with the BTech courses we have AIDS, AML, Computer Science and Business System, and now we have courses of cyber security, and in EC background we have a VLSI, and with the PG courses we have MBA, MCA, and with the PG courses of ME we have a ME CAD-CAM, and then for EEE, EC and for CSE department. With this introduction I just going to move on to a next session of having a GATE coaching and especially in a networks subject. And this is our syllabus that covers in the networks, and where we have 30% of the syllabus is covering, and the questionnaires from networks will be in 15 questions, and it is almost covering a 3% of entire the computer subjects in the subject of related to the computer field. So when we are moving to the GATE coaching, they will enumerate all these syllabus coverage, and especially we have covered in our previous session, we have covered all those sessions with a clear-cut view of covering all these content like protocols, and especially with the OSI layer models, and then we have Ethernet bridging, and all these things will be covered with a sample questionnaires that is asked previously in the previous year question papers. And today I am going to explain you about media access control, that was shortly called as MAC in the field of computer networks, and here it is just a startup of having a addressing mode in the computer networks. So we know that the networks are the interconnected frame structure, and they are majorly delay on the addressing network, that is the complete structure of the routing is completely depends on the networks through the IP addresses. So this is covered through the media access control, and majorly this MAC will provide you two questions from the GATE which is covered in the computer subjects, and those two questions is entirely covering with the MAC address and the complete structure of media access control. And this is the presentation of the complete OSI model, and here I am just going to state you where the MAC is exactly relayed. So the first, we know about the 7 layers, and we already thought about this OSI model, and today I am going to tell you where the exact locations of MAC and its responsibility. So from the figure we can state it that it is in the data link layer, where it has 2 layers of entire coverage, that is LLC, that is a logic link control layer, sublayer, and then MAC sublayer. So these 2 layers is going to enrich the data link layer for addressing mode. The major unit of data link layer is wholly depends on this sublayers. When talk about MAC control, that is the full layer control structured with a major unit of MAC address. So when we talk about address, you already know about IP address. Here I am going to tell you a new type of address, that is media access control address, and shortly it is media with a coverage of network interface controller. So when we talk about NIC NIC card, it is majorly concerned with the MAC layer, and this MAC layer will have a connectivity with this NIC, that is NIC, and that devices will be enriched with the network segments, like we can connect that through the Ethernet, Wi-Fi and Bluetooth technology. So this whole things, the whole structure of these Ethernet or Bluetooth, everything will be enhanced with the help of NIC, and that NIC will have the MAC address. So as you know that the MAC layers and logic link control, all these things will be encompasses with each addressing format. This particular MAC will have a comprise of 6 groups, that is 2 hexadecimal digit and separated, which are separated by hyphens, colons, and then separators. When it has addresses, it is having the structure of hexadecimal, that is 2 hexadecimal digits will covered with the IP address. Then when talk about the channel allocation in MAC layer, we have a static and dynamic. So mostly one of our GATE coaching, when I talked about GATE coaching, the questions is from the dynamic channel allocation, where the entire LAN and MAN connection will be completed with the dynamic channels. And when the dynamic channel allocation, again they have different modes. The first one is about the station model, and second they concentrate on the static single channel assumption, and third it about the collision assumption, and fourth it vary with the continuous and time slotted variations, and fifth is the carrier sense and no carrier sense allocation. So when it is a dynamic, as you know that the dynamic is an environment where it keep on changing. So when it has a dynamic environment, these allocations should be properly in line, and it should have the proper allocation with the LAN and MAN connection. When come to the point of multiple access protocol, so it is derivated from the MAC address. So we are concentrate on the multiple access protocol, where we have several divisions. The first one is about Aloha, and second is the carrier sense multiple access, and you can expect two questions from majorly from this CSMA and collision free protocols. As far as the previous year concerns, the questions are derived from this CSMA as well as Aloha. That's why I concentrate more on these topics. When have a lookup of Aloha, when we mean about Aloha, they introduced the concept in 1970s, and it has a comprising of a one central host with a several connectivity. So those several secondary hosts may have a uplink and downlink controls, and these channels will be collide with maybe a chance of colliding with other channels. That's why there is a time slotted frame in the Aloha, so it can majorly concentrate on these collision possible things, and it also detect the collisions, and even it has segregating the collision in a proper way. So this is what the proper channels allocated in the Aloha concept. See, this is introduced in the year 1970s. And this is a pure Aloha. This is a very first method that adopted through the collision CSMA process, and this MAC address will always have the user interfaces, and these are the time frames that will be controlled, and it was traveling from the A2 and E node. So these layers, when the user interacted and they started to transfer the frames evenly, then there is a possibility of collision, but they will be controlled with the time frame, and this time frame will majorly has the allocation of which part can be collide. So this is the expectation that every data link layer has to be expected. So that expectation will be controlled through the Aloha series. So this time frame will check out each and every frame which is not getting the collision or non-collision. Everything will be controlled when you are seeing this kind of Aloha framework. And this is the pure Aloha format. Aloha will collide and check over that whether the T frame from T0 to T up to the time series which we have even a T0 to 3T plus 3T. So even with these time series, whenever we have the lookup, the entire collision will be checked out, and they separated where the collision is happens. So this is the major functionality of Aloha. So when it collides, the starting state will be in the non-free collision stage, and secondly, when it have a collision with other frame structure, automatically the shaded portion will show you how the collision is happened in the particular time, so that it will be easy to track whether the frame is getting collided or non-collide. So and it is a vulnerable state. So we are easily identifying through the Aloha state and mentioning through the MAC that the so and so frames are getting collided. So this is the major responsibility of Aloha process. And here the graphical structure mention you the throughput, how the each and every atoms of frames is deeping over the concept. Say for example, here the graphical structure is started, and here the pure Aloha mention is the G E of minus to the power minus 2G. This minus 2G or G is representing the atoms per the slotted time. So the packet time, when the series of packets is getting transferred, the entire packets will attempt to have the each and every time frame, and within the time frame the slotted Aloha or the pure Aloha will getting the travel. So here when we come to the point of each and every time set, the throughput, the entire throughput will be calculated, so that we can easily get the process of having the resultant of the comparison of attempted framework along with the slotted time. The entire throughput will be calculated. This is an example how they are getting through the gate questionnaires. So here we are having the formula of adopting the service delay. We can check out the service delay through this process, where the process, the service delay T of a channel with the capacity C, that having the frames of lambda. So whenever we are calculating, suppose we are taken a 10 as a frame sector, then those 10 frames will be processed through the channel C with the delay distortion of t. So this will be calculated through the process of t equal to 1 by mu c by lambda minus lambda. So this is the calculation of service delays, and through this t we are again calculating the entire set of the n segments. So n of t is representing the entire segments of total delay. So this is one of the practical example that consider in the gate coaching. So when you are attempting the gate questionnaires, these kind of questionnaires can be expected with the calculation of the entire delay distortions. This is through the static channel. When coming to the dynamic channels, we have a process of acquiring these properties. So when we adapting to the dynamic channel, this independent traffic, then single channel observable collisions and slotted time, CSA, all these things are the entire important property that adapted with the dynamic allocation, and this multiple access will have the control of these things. So first we saw about Aloha, and now we are going to see about a CSMA. This is what the Aloha will productively given through the collision. So here when we see the first example, we have a time period and the collision happens in one single frame. But now the collision is happening each user's interface. Say for example, A is traveling and B is going to travel, but now here the A and B is getting collided. Then again C is independent of the frames and it is traveling with a packet delay, without a packet delay. And in D we have a starting phase of here, so that here we are expecting the B to be collided here. Again we have a process of entirely going with the E standards and E is getting collided, and here also we have the collision with A. Now even with a single time period there are A, B and E and as well as D getting collided in each and every frame. Here when taking this collision, we have three enhancement of collision, and here we have a two collision. So in same single frame itself we have a packet distortions and we have a delay due to this collision. This is what the pure Aloha will completely check over, and this arbitrary time will be processed for the next set. So here when we have concluded this with shaded informations with a T, we have a process of finding the channel throughput. When the channel throughput getting delayed, definitely there will be the packet loss or a time delay distortions to the user interface. So this should be avoided, and the pure Aloha will identify still this throughput channel. Now we go for the eliminations of these Aloha period. That's why we come to the point of carrier sense multiple access. So when it have a CSMA, even though we have a digital signals or analog signals, the carrier sense will identify with the multiple access control. That's why it depends on the MAC protocol. So when MAC identifies, even though we have a collision detection, it requires only two frequency to find out the collision detection, and it automatically has the process of avoiding it. So the major advantage of using carrier sense multiple accesses, it can detect as well as avoid it. So that's why CSMA/CD is introduced in along with the CSMA. This is a major advancement in the network technology that is adopted in the data link layer. And we have two types of persistence. So when I talk about the frequency and even when radio waves are getting collided, we can have a control over it. So this process will be implemented through the two set of frames. One thing is a one persistent CSMA and second one is the P persistent CSMA. When we have a one persistent, the sender waits for the transmission acknowledgement, then they will send it. So that's why it is meant to be a one persistent, because each and every time the sender will wait for the transmission rate, and again within the random period of time he will accept the acknowledgement. This is what happens in the one persistent. Whereas in P persistent, the probability of finding or reaching the destination is always controlled, and it was enriched in the next frame. So in later cases, the sender monitors the channel and it is going to be in an ideal stage. Immediately he transmits the data. So the sender has the freedom and independent nature to understand the probability, then he can cover the entire set of sending the frames from one area to the another region. So this is what the P persistence will do. The P represents the probability where each and every time the availability and then the delay distortions, and then they find out the monitoring of the channels. So these are covered in the P persistent CSMA. Next, this persistent and non-persistent, here we can see the difference with the pure aloha. When we're working with the pure aloha, we have the curve of having the coverage of a little throughput where it was in a very delayed manner. But in the throughput of, when you're seeing the throughput in the slotted aloha, we have a little increment, and from the point 1 to point 3 we have the arrangements of throughput. So we have a comparisons of load. Based on the load also we can have the probability difference variations. That's why we will go for the one persistent, and then we have a several persistence like 0.5, 0.1 and 0.01. So these persistence with the probability of 0.01, 0.1 and 0.5, they varied with the throughput inheritance. So here the packet per time will be calculated and the corresponding throughput will be concluded while with a different probability sensing. And this is what the CSMA with the collision detection. The next topic is the CSMA with the CD, and here the frames are controlled with a contention period. Say for example, here the transmission period from T0 and we reaches with this frame, but here the contention period starts and each and every frame will be allotted like a slots, and the ideal period will be calculated and then frame will be transferred accordingly. So when the collision detection happens, the time period where even the microsecond or millisecond will be concluded and it will be find out through the CSMA. So when collision is detected, the nodes get stopped and immediately there will be no proper acknowledgement to the sender. So this is processed through the contention slot and it will be getting ceased, and after that interval will be delayed, and again the probability will be chance of moving the entire collision into a free movement of the frames. So this is 3 states. One thing is contention, transmission and idle. So these 3 will be intimated in this diagram. Let's see the contention and then ideal and then the starting of the transmission. So these are the 3 modes in the CSMA CD. Next, this is an example where we have 8 contention slots. So from 0 to 7 the frame getting started and the sender started to move the frames. So here we have the process of 1, 3 and 7, that is in the time period of this particular T0, the 1, 3 and 7 contention slots getting engaged and they are started to move the frames, and the 1, 3, 7 is now moved. Next, in the second contention, this 1 and 5 is now getting adapted and availability is now free from 7 and it is move on here. So 1, 1, 1. So again we have a 1 and 5 to be the particular time frames, and again we have a 2 alone getting engaged here. So here we mention this 2 to be a contention slot. So when we have these kind of process, immediately we can understand which is ideal, which is transmitted and which is contention. So this is a very major functionality that was great in the CSMA CD process. And this is the bit times. Even with the time period from the T0 to 3T, we can have a good proper interval so that we can have a good enumerations of all these things. So when it find out these kind of resultant, the final result will identify that 1, 0, 1, 2, 3. During this time period, it automatically alerts. Say for example, station 1001 sees this 1 and gives up. So when I have a 1001, it automatically gives up the 1. Again, station 0010 and 010 see this 1 and gives up. So here 0010, the second example 0010, 010, they adapted with the time period and they taken over the 1. So similarly we are calculating the contention slots and again they will transmitted with the calculation of ideal slots. This is the major functionality. And this is how the radio range will be set up in the wireless LAN. So far we have seen a pure aloha, slotted aloha, CSMA CD, and now we are moving to the wireless LAN. So here when we have a radio range of A to D, the A gets engaged and this is the first transmission, and again second B is getting engaged and here the radio range will be transmitted. So these two, consider into these 2 example, this AB is now transmitted and radio range will be flexible and they are calculated, and this wireless LAN with the LAN will be concluded like this. Say for example, here the RT is, that is a time for reverting and the time for calculation. We have the aloha process. So first there is a A, B, C, D. Here A, B, E are getting engaged and here A, B again they are engaged. So in the first one, the sending process of RTS is is in the centroid moment, and they are calculating from the calculations of the frame sectors A to B and then C. Again the similar pattern will be for the B's transmission. Here they check for the B, and B to A if we transmitted, they will calculate CTS. So this RTS and CTS is a major responsibility. They find out the transmissions of from the frame A to B and then B to A. So this is similar patterns of a MACA protocol, and this access control is majorly implemented in wireless LAN. And these are the Ethernet. The Ethernet bridging, you have a knowledge of Ethernet bridging, and this is a major separate topic in the gate coaching. Here we have even though it was under the Ethernet, but they are more giving concentrate on the Ethernet process. So Ethernet, we have again the bridging concept, and they have the cabling, and then we have the Manchester encoding, we have a MAC sublayer, we have a fast Ethernet, gigabit Ethernet. All these things will be in the separate topic of the gate videos. And this is what the internet cabling structure, and they have a full cables of length of this one, and this we can expect the problems from these kind of nodes and segments, and even with the cabling process. This is the expected questions in the Ethernet bridging concept. And this is the overall control of 10 base 5, 2 and T. So here we have the unit of twisted pair. Here we have the twisted pair, and this is a transceiver controller, and this is a transceiver cable. So these cabling connections will be enriched with a certain length of some 0.5 or 0.2. Here it will be the connector, and here we have the hub. You know about the switches and hubs, where the router will be connected with these hubs and for the each and interconnector networks. And this is what the decision trees and other classifications can be done, and this cable technology always streamline with the individual component, and it starts from the A to B, means the entire unit will be transferred in this capacity, and here it even more having the capacity channels, and even we have the delay distortions. But in the place of spine, we have a divisions, and based on the classifications, even we can travel more than comparing to the cabling. And here in the tree segments, we have the segmented. Here we can even have the structure of repeaters hub, where the equal importance will be given to all the node, and the interconnected node will be ideal, and immediately they will get the frames, and if they are busy, then again the ideal mode of set of nodes will be getting transmitted. And this is what the Ethernet cabling, and there the complete set of bit streams, binary encoding, Manchester encoding, differential. So here the frame sets transitions based on the transition sector. The entire encoding will happen, and each and every encoding will be benefited to the Ethernet bridging. And this is the frame format for Ethernet, and we have a 8-bit node, 8 bytes, and here the destination address will be settled over, and this for each and every time they will check, and checksum will be processed, and if any fault detection, immediately it sends to the sender. This is the major advantages that has the Ethernet cable. Then immediately we get the sender's default mode of segments, and we can overrule that through the Ethernet frames. And when you have a collisions, the Ethernet based on the major sectors of senders and receiver, immediately it pass over the collisions, and even comparing to the CSMA and Aloha, the Ethernet will produces the best way of transmitting the data from the sender to receiver. And this is the separate unit of the hub, that is from the sender to host, or host to receiver, how it is transmitting. Each and every transmitter have the 10 base T connection, and these are all the important switched Ethernet process that can be a one part of the question in the YouTube gate coaching. And now we have the 100 base 10. So far we have seen 10 base, and now it is a 100 base T, and here each and every cables are twisted and with the fiber optics. And this is the gigabit Ethernet, and it will be covered in the Ethernet bridging concept. And now we move on to the questionnaires, where the gate YouTube we can concentrate on these questionnaires, because repeatedly they will ask for the CSMA and the calculations of the bandwidth and the delay. So when we have these questions, they given the Aloha medium, they started with the Aloha medium with a length of 1000 bits, and here the channel transmission rate is 1 microbillion per second, and it's up to the aggregate number of transmission with a new frame set. Now the question is about throughput. That's why I mentioned mentioned you that throughput calculation and the delay time calculation is a major two important topic that concentrate on the gate entrance examinations. So here the throughput of the network will be calculated in this process. The first, it's about the frame transmission time. So it has the calculation of TFR by L by D, where we have to give the 1000 by 10 to the power 6. So it obviously we getting the 1 microsecond. And now with the calculations of frames, we need to give the throughput. First we find out the frames in the seconds. So from the given input, we have concluded 1000 frames in 1 second. Now we have to change that into 1 millisecond. So 1 second is 1000 frame, and for the 1 millisecond, 1 frame, how it can be calculated? Then the G is this 1. The answer is 1. With this G, we have to give the process of possibility of getting the throughput is, so 0.13534 into 1000 frames. So nearly it happens of throughput of 135. So this is what the calculations mean in the gate video. Next, the second questionnaire is about calculating the network layer and routing concept, where the first pair of digital sectors is controlled from the MAC. That you know. But here they give you a little bit confusion state that whether these layers are combined and how they are given in the particular networking layer. So here we need to have a knowledge of all the controls of the layers topologies. So first the question is about, in the following pairs of OSF protocol layer and its functionality, which is the incorrect pair. So as you know that there are so many protocols and so many layers that control the protocols, but you don't know the combinations of the way they are interconnected. First, it's about network layer and routing. So you know that the routing is majorly involved in the network, and it is a major unit of network layer. So the first one is correct. So we have the entire functionality. The second is about data link layer and bit synchronization. So bit synchronization is always you know that the physical layer handles over the bit synchronization. That's why the OSI model will reject the bit synchronization in data link. So there is no matching with the data link layer and bit synchronization. So obviously it is the incorrect pair. And third is the transport layer and end-to-end processor, and it is a major functionality of the transport layer. And here we have the control of MAC. So media access control, sublayer and channel sharing. So this is done through the MAC, and the channel is subscribed with the MAC layer. So this is the correct pair. So when making the confusions with the correct pair of decisions, you have to concentrate on all the layers, and you have to have thorough knowledge in the layers. So here the second one is the incorrect pair. So likewise we can expect two questions from the media access control, that is a MAC layer in the networks of the network subjects in the gate video. And thank you. And here we have ended with the sessions of explaining the media access control, and we will catch you in the next session. Thank you.